always predict with my theory that the electrons do this or that or whatever. But does your theory reflect reality, or is it just a mathematical circus like Ptolemy's was? See, David Bohm wants to do away with that and say we can know reality. We can give a true, a good, a right explanation, an objective explanation, strange as that may be. So then David Bohm says, experimental predictions are only one aspect of a theory. Bingo! Perfect! That's right. To predict what will happen in an experiment is one aspect of a theory. Okay? Then he says the other aspect of a theory, a very important one, is to explain what's going on, to actually give you a coherent picture. So it's fine, isn't it? It's just fine for Ptolemy to be able to tell us where Mars is going to come up at what hour. That's fine. But he's not telling us why it comes up there. You know? Doesn't that sound like the quantum mechanics people today? They say, we can tell you where the electron's likely to pop up, but nobody knows anything about why. It's impossible to know about why, because perception creates reality. And the electron isn't even in a real situation until somebody measures it, and then it pops into reality, right? And all that nonsense. That's Schrodinger's cat experiment. Actually, I rest my case on that. Now the questioner, the interviewer, says, your interpretation, when it's known, when people know anything about it at all, the general public, he says, are you sure they're understanding it in the right way or whatever? And Bohm says, I don't know, there's no way for me to know that, but he says, the other theory of quantum mechanics that's out there, Niels Bohr, he says that theory is not generally understood by people because it's not really intelligible. He does not have very much respect for the current view of quantum mechanics, not much at all. He says it's so abstract and difficult that the general populace really can't understand what it says. And abstract and difficult is one word for it. But there are extra problems in there, like Niels Bohr using words like complementary truths when he has a contradiction in his theory or in his outline or whatever. And there are two things that cannot both be true, right? And he says those are complementary truths, right? So then there are roadblocks like that in there, epistemological roadblocks to the understanding. And then Bohm says, I think my interpretation, he says this interpretation will make this whole field more accessible generally, and perhaps allow connections to other fields therefore. Now, they're currently trying to connect quantum mechanics to other fields, right? You take quantum unknowableness, we can never know anything about it, and project that onto all kinds of things in reality. How we know that the universe isn't a 12-dimension hologram of a soccer ball, you know? Maybe it is, according to their theory. And if we have a good interpretation, if we have a proper interpretation of quantum mechanics, then we'll be able to take truths from the subatomic realm and project them out into the universe. Now, Newton came out with his views and said, he said the planets go around the sun because of gravity. There's nobody there pushing them or pointing at them or doing woodgy spells. They just go because of a mechanistic thing called gravity. And then people said, oh my goodness, so the entire universe is just like a big clock. That's determinism. You know, everybody, we all think we have our part, we all think we're independent of the whole, but it's actually just a set of mechanical laws. So then here comes Darwin, and he shows there is another realm, right? It's the same as Newton. Here's a realm in which a law holds true. There's some sort of a mechanical law that holds true across the board. So people were wrong to overgeneralize about Newton's system. Newton's system of determinism and how the planet moves and stuff, and the moon and stuff, doesn't necessarily have to be carried over into our private lives. We actually do still have independent free will, even though gravity is pulling the Earth towards the sun. And that's what's happening with quantum mechanics. They are overgeneralizing, and they are starting with bad theories. It's fine to overgeneralize from a good theory. That still doesn't help you. But what about overgeneralizing from a bad theory? So you get a general idea that we can't know anything about anything and all different parts are not connected and there is no whole that we can know anything about. And you start putting that, just those three sentences, Put them into any field you want. Put them into education. Put them into politics. Put them into religion. Put them into economics. There is no whole we can know anything about. All we can know is any individual part, and so on. And there are no general rules for everything. All we can know is possible outcomes and probabilities and stuff. Take that into any given field in human knowledge, and you're going to destroy the field. Now the questioner says, you've been criticized for bringing back a classical view of physics. You're just stepping back to Newton or whatever. And he says, no, no, no. The idea of interaction at a distance, in other words, the form doing it, was totally alien to the classical view. You wouldn't be able to have a form carry information in the classical view. The classical view does not include this. And the quantum view, today's quantum view, does not have that idea. So here we have a new inductive leap that had to be reached from evidence in the quantum world. The same evidence, which Niels Bohr would say, does not even point to these things David Bohm's talking about, because he rejects the idea that we can know anything at all anyway. So David Bohm says, I'm introducing a completely entirely new concept to classical physics, which is that information has some effect, very much an important effect. That information, or the form that something takes, is as important, or more important in some cases, than the physical nature, the mechanistic nature of whatever thing's in question. And Bohm says, the fact that you think of a particle doesn't mean that it's classical mechanics, you see. That's what he sees that his critics as saying. That, look, he still believes in a particle, a thing, an actual entity that we can know something about, when actually all this is created by our perception and stuff, and it's not independent of us, we're part of the system and whatever. And he says, yeah, sure, I'm bringing up particles again. I'm saying that they exist like they used to say they exist, but it doesn't necessarily mean I'm a classical physicist. Then he says it's very difficult to explain, but it's the question of whether or not they're going to take the wave function as the entire story. He says, I have this particle, you see. It's not just a wave function that sometimes acts like a particle under certain conditions. It is a wave function with a particle embedded in it. And he's going back to particles. It's not just the creation of things ad hoc, like Niels Bohr thinks. When you look at something, it creates it. You know, think of Schrodinger and the cat. You open the box, and up until then it's in quantum limbo, right? Nonsense, nonsense, because Niels Bohr says the wave function is one thing, you know, the probability, but there's a particle in that wave function, and the wave function's telling the particle what to do. He adds a particle. Now, how could Bohr have a wave function? How could they even believe in this wave function, which is some knowledge about reality? So Bohr didn't call it that. He didn't think that it was a law or knowledge we had about reality. He called it an algorithm for calculating the possibilities. It's not really knowledge, it's just our approximation of the system. So the sad thing is sometimes they do have knowledge about reality. They know things about what electrons do and stuff, and they say we don't have any knowledge. This is just all probability and statistics, you know. And David Bohm thinks that there are actually things there, objects, particles, which we can know something about. We can say something about the entire universe. Things that are true all across the universe. Not that we're pretty sure they'll be true, or they're likely to be true, there's very high probability they'll be, but that they are true. That's different from the current view that you can walk along and suddenly drop through the floor if there was a quantum blip and the hardness of the floor reduced or whatever all of a sudden randomly. Or that black holes could pop, or the statue can wave at you or whatever under conditions of extremely improbable whatever. That is all going to have to go. All that's going to have to go. Feynman, I thought is how it was pronounced, but Feynman says that this wave function is a description of the entire quantum reality. That the wave function is quantum reality. The probability wave function is quantum reality. And Niels Bohr would take exception even to that. Niels Bohr wouldn't even go that far, says David Bohm in his interview. He says that Neil would say there isn't even a quantum reality to really talk about. Now the interviewer says, so